everybody, Dutch Sense here. 11:50 a.m. Central Time on Friday, August 23rd, 2013. And we're looking at the Weather Channel, and I've got their radar turned on as well as their storm tracking. And I want to draw your attention to something that was just standing out here on the map. You can see it here, a strong cell detected up in Nebraska, and we also saw a few strong cells detected here in Kansas on a clear day. Okay, now what's causing that? Why is there actually a storm detected in the middle of the day on a clear day in Nebraska and Kansas? Well, let me take you over to my YouTube channel first and show you guys something that happened a day ago. And I put out a video. It's on my backup channel, but I've got it over here. It's the radar pulse Harp-Ring scalar square outbreak that occurred over the same area. Okay, here we go. Let me open up the screen here and turn this on HD so you can see it a little better. Okay, here's Nebraska, all right, here's Iowa, and you can see there's a large scalar square outbreak that occurred in the same area. So let's just go ahead and take a look and see what's going on in Kansas. And to do that, let's look at the 1 km view. And again, you can see here just cloudy, okay, just a few clouds, no storms actually there. And we'll go ahead and turn on radar, and then you'll see what's actually causing this storm detection. There it is. All right, so let's back this up. You're going to see a series of targeted radar pulses looking into these clouds here. Okay, and you'll see that it's coming from basically 2 stations, but one also down here in Oklahoma. But we'll just go through this again. And you see they're pulsing these in the same direction, overlapping. Now, if you guys have paid attention to Lieutenant Colonel Thomas Bearden's conversations going back through the 1980s, talking about scalar radar and the combining the use of 2 or more radar signals to cause energy to form at a distance. This ties in with the 1975 NASA radar experiments where they targeted a radar pulse and were able to transmit electricity across a distance. So you can imagine there's 2 radars, both pulsing in one direction. You also have to figure each pulse is 750,000 watts at 2.45 gigahertz. And that's if they're operating at full function. If they're operating in pulse mode, then we're talking in the megahertz. Okay, we're talking between 0 and 19 megahertz. So NexRad overlapping on that capability, and I believe it's actually producing heating at a distance, cloud condensation nuclei, actual CCN, which is causing the computer, let's go back over here, which is causing the computer to detect storm activity where there actually is none. Now you'll see the storm signatures are now not detected by the computer, only down here in Oklahoma, where there is a little bit of storm breakout you can see occurring here. Okay, but here, this is no storm activity, even though it's detecting some precipitation. I was detecting strong cell storms just a few minutes ago, right up here, where it's clear. All right? Hang in there, folks. Much love. I hope that gives you some explanation as to what's going on. So when you see these ghost signals, these ghost storms, you know that they're being caused by frequency itself. Frequency is inducing CCN, which is causing the computer to actually see a storm return when no storm is actually present. Wild. Hang in there, folks.